I don't just want to speed up my Python code. I want to speed up how quickly I can write my Python code. Welcome everybody, I'm James Powell, and today we're going to be talking about tightening your iteration loop. We're going to talk about how to improve the process by which you deliver code, whether that code happens to be very fast, very high performance code, or just code that solves a simple problem for yourself. But I want to answer for you a couple of questions, but I want to give you some principles, overlapping principles that I use to decide whether my iteration loop is as tight as it can be and whether I can improve it. Before I get into those principles, I want to talk to you broadly about some motivation for this. But note, I am as guilty as anybody of giving advice that I might not take myself. And so there is room for improvement in all of our processes. I know, even putting together these notes, that there's things which I've slipped a little bit on doing that I need to do a little bit more of in my work. Well, let's take a look. When we talk about the iteration loop, we can analogize this to another loop you may have heard of, the OODA loop introduced by John Boyd in the 1970s. This is the observe, orient, decide, and act loop that was used by fighter pilots in order to improve their operational efficiency when dogfighting. And the general idea here is that the tighter their OODA loop, the more effective they can be in these very fast-moving situations. Specifically, that the idea of higher agility can overcome raw power. You may have even seen this in some cases where we have done sessions on topics that we are not experts at. For example, I'm okay at JavaScript. I am not a JavaScript expert, but I can churn through JavaScript code very quickly because I have a fast iteration loop. And so when I don't quite know what I'm doing, I can try a bunch of different things and then quickly orientate myself around, okay, I think this is what's going to happen. Here's my hypothesis. I can act and then tighten that loop and see did that work or not. When we talk about our iteration loop, we're typically talking about something that can be measured by the time that it takes between making a change and seeing the effect of that change. And one of the dominating principles, I think, of tightening that iteration loop is making sure that you can make a single line change to your code and immediately see the result. Many of the principles that we see will overlap with this idea or further empower this idea. But the general idea is something like this. And you've all seen me do examples like this before. I have a pandas series. I say, oh, I need to do some operation on this pandas series. And in order for that operation to work, I need the index levels to be swapped. Is it a swap levels? Nope, it's not a swap levels. Is it a index.swap levels? No, it's not an index.swap levels. Is it an index.swap underscore level? Nope, it's an index swap level. Okay, there we go. And I guess maybe I don't need to perform this on the index. I can perform it like that with then a reset index or a sort index afterwards. Ooh, let's close some of these. And what you can see here is the idea of the iteration loop. I don't know off the top of my head what the names of all the different methods in pandas are, but I know that if I can quickly make a change and see the result of that change and immediately see the result of that change, the tighter I can make that, the faster I can go. I can actually trade off meticulous memorization of the details of these with just moving very, very, very quickly. There are some general guidances that I have for my own iteration loop in order for it to be effective. One, I generally want that iteration loop to be under about a second. This is something that's a little bit controversial because when we talk about things like unit tests, there's a lot of guidance here that your unit test suite should either be runnable very, very quickly, or it should be hierarchically structured so that the most obvious tests run very quickly, and then the more sophisticated or the more nitty-gritty tests run, at the end of that. But a unit test suite running in under 1 second, or a continuous integration pass going in under 1 second, that's quite aggressive. It's my view that it's not necessarily 1 second that we want this to be less than, but we want this to be less than the speed of our actions. That is to say, I want to be able to see the result of an action I do faster than it takes for me to perform that action. So even though I might fumble a little bit when I'm typing, I might make a bunch of typos, it's generally the case that I can see the result of this more or less as quickly as I can type these results. In fact, if I had set this file to auto-saving, I might even see those results stream on me as I go. And as a consequence, I'm not waiting, or I'm not trying to batch up my actions, or I'm not seeing some poor synchronization between my actions and the results as a consequence of the iteration loop being too broad. You've all experienced this. In cases where that iteration loop might be 3 or 4 minutes, you have to kick off a process that runs something else. You'll kick off the process, a compilation, a unit test suite, whatever the case may be, and 3 minutes into running it, you'll say, oh, I just spotted there's a typo there. And you'll kill the process and you'll start over with the typo fixed. And then 2 minutes into the next run, you'll say, oh, actually, I forgot to unpack this structure. Another trivial error will hit you. And it's generally the case that unless you take a deep breath and you plan out each of those steps and you batch those up, well, it's the case you're going to see this just dragging on and on and on. I know you've all seen this happen in your work where there was some script and there was some error in that script and you fiddled with it, but nothing seemed to work and you were just wasting your time. And the longer it takes for you to see that that didn't work, the longer this stretches on. Generally, what I see is that the speed of your overall operation grows non-linearly with the tightness of the iteration loop, which is to say that basically, if it's under the speed of your action or near the speed of your action, that's one regime. Between maybe 1 second and say 10 seconds, maybe the speed of your attention span, that's another regime. So I don't think a 2-second iteration loop is actually twice as efficient as a 4-second iteration loop. I don't think that's really the case. But I think that within some regime tied to the amount of attention span you have or the amount of time you have before you start wandering or you start thinking about something else or you start evaluating something that you pre-assess something else, that's another regime. And the other regime is anything longer than that. I think past a certain point, it is the case that a 2-minute iteration loop may genuinely be more than 2 times slower than a 1-minute iteration loop. I've experienced this myself in cases where a altogether not particularly loose iteration loop, maybe 3 minutes, ended up with me working until 10 or 11 p.m. at night to solve a problem, even though the total number of passes that I had were very few because there are all these nitty-gritty details. When you think about it, when the iteration loop is larger than the speed of your smallest incremental action, then necessarily you're going to have to batch up those actions. But what that also then means is every change that you see is subject to multiple, or every result you see is subject to multiple changes. So if you did 5 different things, you changed 5 lines of code, then you kicked off your 1-minute unit test, and there's a failure, how do you know that it's not somewhere in the power set of all 5 changes? When you tighten that iteration loop down to the speed of one individual action, then you're guaranteed that the mistake that you made is a consequence of the exact action that you performed. And you can see how if you have something akin to an OODA loop, you're actually tightening that decision action portion, the setting of a hypothesis, and then the testing of that hypothesis, the acting on that hypothesis, and then reorientating yourself.